All right. Hello and welcome to another one of these pcalc streams here. And last time we left off, we were doing this backend, or not the backend. We were doing this compiling things the hard way. Um, the dash cc1 to Clang so that we kind of have the lowest level interface to Clang to work with. And I think we pretty much got everything for the X11 build set up, except that we don't do this yet. And that's because we haven't seen how it would actually work, because the compilation never gets this far, because we need to actually fix our compiler errors. So that might be what we're doing today, is fixing those compiler errors. And one thing I'm curious about is if you just say like Clang like this, will it tell you what it tries to run without passing it a test file to compile? So it looks like it does not, because it knows there is no file to compile. But we do have a file that we can work with. So if I just do this on test.c, okay, so when it breaks it up into multiple steps, it actually calls the linker directly for the linking stage. That's kind of interesting. So yeah, the first thing we do now in this one, we actually start by doing an object file. So we just do the object file and then we do the linking if we just run it on the test program. But on the actual project, we saw that it's a little bit more complicated than that. It first of all, it runs the preprocessor, and you know what? I see why it's doing that, actually, because the file we're compiling is the Linux x86 64 start.s, so it's running the C preprocessor on that because we're doing assembler with CPP. So it assumes this file could have like C preprocessor stuff in it. So it runs the preprocessor on that and outputs the preprocessed file right here. So this has all the preprocessor stuff expanded in it, but it's still just an assembly file. And then this one right here, hello Miblo. So let me see here. This is outputting an object file from the assembly file. So the CC1 AS is actually doing the assembler. Have you annotated episodes since I got the second webcam here? I've got the High Five One cam now. I don't remember what episode I started using that in, but here we have this is the CC1 AS is apparently just it calls the assembler. So I don't know what it's using for the actual assembly. If it uses like the GNU assembler or if they have like their own thing with LLVM. Ah, all right. And then we get the object file from this assembly file and we call it again. And this one, it's just compiling C code. And here we see the main file's object file. And then after that, there's going to be a linker stage to link those two object files together that we never get to. So let's see what happens. Okay, so here's the line that builds the test program using the Linux backend. So if we do that, and we say verbose, so here we can see the actual linking line that happens in that case. So it ends up setting a bunch of directories for linking, and it specifies the dynamic linker to use. And we see it uses the gold linker for this. But other than that, it's just a few flags that are being passed to the linker. Because all these flags don't matter at all. And then these are our files that we're linking, and there's the output. So it looks like this is specifying the executable format and the architecture. And I've seen this stuff in object files, but I don't totally understand what it's for. I think it's like some kind of exception handling or something, the EH. HDR. EH frame header. But what is an EH frame is my question. Exception header. Okay, but what is an exception header for? It says it like it's specific to dwarf, and that's like debugging stuff. So maybe it's specific to debugging. Well, this is saying EH equals exception handling, and it's talking about like frame unwinding. So it seems like it is for like exception handling stuff. That's kind of what I thought. So we shouldn't need that at all because, we're just doing like plain old C. And then this is saying it's a position independent executable. Okay. So the interesting thing to me here is my understanding is that we don't need to break it up into multiple steps like they're doing here. At least that's what I was thinking. But if that's the case, I'm not sure how you would specify the linker to use, for example, without splitting it up. And I'm not sure how it will handle the assembly file if we're passing it into just CC1. So I still have some questions about that, I guess. So right now I'm wondering, it seems like when they do the CC1 AS, they don't need to specify that this is an assembly file. But maybe if you specify that with the CC1, it'll handle it. I don't know. Well, let's start off by I think the first thing I'm gonna do is temporarily comment these ones out and use the old method. And then doing it that way, we're just going to get the program compiling and running. And then once we have that, we'll continue with the build scripts. Alright, so I believe I don't need this anymore. And let's try a build here. I must have missed one that I was supposed to comment out. What is it complaining about? Aha. Alright, now let's fix these errors. So I'm going to start with this warning. So for the invalid no return, I'm wondering if I just mark it as a no return, because it's not actually marked as no return. So here we see the attribute for it. So let me just grab that and try sticking it in there, and we'll see what happens. So it still complains about it. So it seems like this person is wondering the same thing. Oh, and there's a built-in for it. Let's give that built-in a try. All right, that took care of that warning. Now the next one is that we are returning and doing this function call here, but we don't forward declare it. So the solution there would just be to forward declare it. And yeah, I already did that in the XCB backend, and this is supposed to be int. Okay, it looks like we have a warning telling us that with this order of operations, it's not going to do what we're expecting it to do. So where is that? Line 143. Now, I probably want to double check that this is actually the ordering that we want. It looks like it is what you'd be intending to do here, but I want to actually confirm that to be the case. Let's take a look at what the XCB source code does. Okay, it looks like it's defined in xcb xid.c. So they actually complicate it a bit. So let me reference the so if I can find it, I'd like to reference the post that that originally convinced me to do the X11 backend. You know, I think I posted it on Twitter. Let's see, how long have I been working on this backend? I don't remember when I started it. Okay, I said right here. There it is, right there. Okay, so here you can see theirs. So it says we need to find an unused value above ID base that fits in the mask of ID mask. So is this specified by the protocol? Is my question, I guess. Here, let's switch to our proper workspace. All right, now So this has like a list of all the requests. Events. So they have identifier in the glossary here. But the index only lists it in the glossary. I was wondering if they like specify it in the protocol. Okay, here we go. The resource ID mask contains a single contiguous set of bits, at least 18. The client allocates resource IDs for types window, pixmap, cursor, font, gcontext, and color map by choosing a value with only some subset of these bits set and ORing it with resource ID base. So yeah, what that's saying is the and should be before the or, because you pick an ID within the mask here, and then you OR it with the base. So if I'm reading the spec correctly, this is what we want. Of course, I'm not handling like, if ID wraps around, if you overflow, then this would be buggy. But for now, we're going to assume that's not going to be an issue. I mean, I don't really know what you would even do in that case, because if it goes that far, it means you've, used up every possible ID. Okay, it says the client is not restricted to linear or contiguous allocation of resource IDs. Once an ID has been freed, it can be reused. So yeah, we could make the ID generation more complicated if we need to, is the takeaway there. but right now I don't think we're going to need to. I'm pretty sure all the IDs I use are set up in the create window, and after that I don't need to get any IDs again. Uh, in which case it won't be a problem. But if I like need to get an ID to do like rendering every time it renders something, then we'd have an actual problem that we need to address. So just something to keep in mind. Something to keep in the back of our minds here. All right, the next one is undeclared identifier query on 161. Okay. So that is correct. What was I doing here? That's the question. I vaguely remember when I was writing this code. I wrote it in like a test program, just a side program as a little test to make sure it was working correctly. Because what we're doing here is we're iterating over the environment variables, um, trying to search for a um, particular thing. So the query, I take it, would be the environment variable we're looking for, which would be display. So we know what it's supposed to be, but before I test that, I want to just look on my laptop and see if I can find the original test program that I wrote. I don't know if I still have it, but I'm just curious, so I'm going to take a look. Alright, no, I don't have the original program, but we can figure out what it was supposed to be. So I'm pretty sure we're either searching for just display like this or display equals, you know, something like that. So let's just read over the code here. So the first thing we do is we grab the length of the current string we're iterating over, and we get the length of the query. Now this could be done outside of the loop. I'll put this stuff in here though. Okay, now I'm saying +2 on the query length. So I want to print them out in a test program and see what they look like, I guess. So let's just take this code here. And we're just going to make a temporary test.c file. Okay, so the first thing I'm going to do is comment out our code. So we just iterate over them, and for each string we're just going to print it. And this will show us what the environment looks like. And we got a bunch of garbage. So what did we do wrong here? Okay. There we go. So yeah, it is in equals before the stuff there. Okay, there's display right there. So I'm saying if the length of the um, the environment variable is less than the query length plus 2, then we skip over it. I'm wondering if at minimum it's going to be the colon and the 0, which would explain the plus 2, right? Because it has to be at least, we want at least this much, and then, it should actually equal something. So there'd be at least 2 characters there. So then I'm setting up a match length, and I'm iterating over each character in the variable, the string, I guess you'd say. And so, once we've iterated over it all, if the match length is equal to the query length, then we've got the display string. And that's all there is to it. So that makes sense. I think now, where did I put that? Where was the test program? Oh, right here. So we're just going to give it a try here. So it looks like my code was by and large calling it str instead of string entirely written out. So if I just change it to this, I think we should be good. Now, I never remember, with the type def, does it go before or after? You put the type and then what you're calling it. So I did that right. So yeah, we get the display string successfully there. So I believe that should be good as I have it now. Okay, 182. We forgot to pass the context. Same thing on 212. Okay, and the other thing I just remembered is all of these warn statements I was doing aren't really correct because warn doesn't work like printf. I was thinking it would, work like printf, but that is not what I implemented. So I'm thinking we should probably make a separate one for debug that does work like printf, because that's what I want. So first of all, I believe it was also telling us in the warnings that these need to be, well, I don't know about the header actually. Maybe not the header. Yeah, not the header, but the rest of them. Here, I'll just record a macro for this. Actually, I probably shouldn't put that on 2. And we'll see if it works. So, well, that's not what I wanted. Okay, yeah, that's working fine. Now I'm going to replace every instance of warn in this section with debug. Now I just need to make the debug function and we'll be good to go. We really don't need the curly braces either, honestly. So let's go back to platform common here. Now it needs to take variable, variadic arguments. So let me see how sprintf goes about doing that. Okay, so you say char const star format, and then you do the ... So that's what we're going to do. I don't think I really need to make it const. Like if you cast to const when it's passed into sprintf, I think that should be fine. Okay, so basically what I'm gonna want to do is calculate the length, allocate the memory for it, and then do the sprintf call, and then write the result of that. So let me think about this for a second. So I'm gonna need to iterate over it myself before I pass it off. In order to calculate the proper length for everything. I'm just wondering, because this is a debug thing, so we can do, you know, silly hacks. Like, I know I'm not going to be passing super huge strings to it, so, you know, I feel like if I just have and how big should we make it? And we'll just increase that if we need bigger, basically. That's how we're gonna do that. And yeah, I'm just gonna say I guess I don't even need the context, do I? Because I'm not going to be using the region allocator for debug. Uh, so basically I'm just going to do this and then or now we just need to get the variable arguments out of it, which you just do like that. So there is a really hacky, simple printer for us. Now this doesn't append new lines either, so we're going to need to put the new lines in the formatting. Okay, so we take that away, we add a new line. Alright, now we need the new lines. Unused variable. I forgot to use the actual buffer. Alright, we're getting there now. So we've got 5 warnings and 1 error left to fix. So the first one is the field initializers for our sock address. Where is that? Oh, I see. Okay, so there's just 2 members. Now, can I fill an array with zeros like that? Let's find out. Undeclared identifier SRV length 237. So I'm guessing that's what I wanted there. Looks right to me. Okay, so seems like we got farther along in the compilation. So we're getting undefined references in third-party libraries and undefined references to environ in platform X11. memset in main. Okay. Memset in here too. And these ones, stack, check, fail. Interesting. Okay, and we have plt write and exit here. So the first one I want to look into is environ in X11. This should not be marked extern. I think that's the problem there. So let me just see if that, yeah, that got rid of those. So we just need to do these now. Let me take a look at the ones in platform common as well while we're at it. So plt write and plt exit. That would be because I didn't implement them yet. Okay, now it's just the memsets and the stack check fail. I think that's what the CHK is. And I don't think I'm explicitly using memset, but I think it's the compiler's generating calls to memset is what's happening there. Yeah, so you can see I don't use memset in main.c, but lines 4, 8, and 9 generate a memset call. So when I initialize this structure, for example, that's doing a memset. Same here and here. So whenever I initialize structures like this, basically is generating a memset. Now, I don't think we would get a memset if we didn't do it this way. So if we initialized each member, So it has begin, end, current, and then two flags are alignment and flags. I mean, ultimately, we might just want to define a memset at some point. Hmm. Now that's interesting. I marked the begin and end as const pointers. But I mean, the actual region is getting initialized in the PLT inits. So, I mean, this is what's going to cause us to generate memsets in when we actually do the initialization. And if we keep those marked as consts, I think we're going to have to do it with a memset. I think that's the only way to do it if they're marked const like that. but I feel like we can just not set this to anything because we're just going to initialize it in the PLT init anyway. We'll still need to implement a memset unless I patch the library. And so these are the other ones. And I feel like I should at least do the thing where you say the name of the member you're setting. Okay, so we have sig key type, and then a union that's either special or sim called key. So what's the syntax for that? Okay, and then we have the key type. Okay, so now we've got those structures filled out a little bit cleaner. And like I say, I think we're gonna leave it this way, but we're gonna have to implement memset. So that's the current plan. So I'm gonna put a to do in here. And then the other one is the stack check fail thing. And I'm not sure what that's. What's generating that? It says line 0 for those. think we're going to need to search that. You know, that might be because of the stack protector. Something to do with that. I'm just curious. I don't know. So it looks like it is something that's generated to detect stack overflows. So it's definitely a stack protector thing. But I don't know why the stack check fail thing wouldn't be implemented if it's like a built-in provided by the compiler for stack protection. So let's try to figure out why it's not defined. I mean, I guess that's a linker error. So we maybe need to link against something in order to use it. So, I mean, we can tell it to not use the stack protector. Or we could tell it to link with SSP, I guess. So let's try linking that in debug build and see if that helps. Stack protector. Okay, here's our debug flags. So that doesn't seem to have helped. It couldn't find SSP. So I wonder what we're supposed to link against. If it's not SSP, I'm assuming I have whatever I need installed on my system to use this, because I'd imagine like it would come with Clang. So this to me is suggesting that it's in libc for Clang. So I'm getting the feeling that if we want to use the stack protector, we need to link against libc. So right now I'm feeling like we should probably just not use the stack protector. So in that case, we're going to want to take that out of the hard mode settings. And we're going to want to take it out here. And I think we're going to want to put in right here that we want no stack protector. So what was the setting for that? No stack protector. Okay, okay, so that's what the problem was here. Dash F slash dash dash auxiliary may not be used without shared. I'm wondering if I should not be passing it to the linker, but instead to Clang or something. Okay, here we go. So now the only linker errors are the fact that we don't have a memset. So I'm going to come back to that after we fix the compiler warnings. Okay, so a lot of these are just unused variables, and I don't want to see those because it's an incomplete implementation, of course, so obviously there are going to be a lot of unused variables. And we had an implicit string concatenation there because I forgot a comma. Why did I still get unused variables? Oh, it's not supposed to have an S on the end. Alright, now we're getting some more reasonable errors, or warnings, I mean. So let's just start from the top, I guess. Okay, missing initializer 249. Okay, what's next? 167, shortening is 64 to 32. I see no reason why those can't be size T's. I think that would be the appropriate type for those. Okay, so now we have a comparison of different size. Where is that? 174. So I'm just going to cast J up there. I mean, I guess we might as well just make J a size T2. Okay, this one happens at 180. This one on 214. Why did I mark this as unsigned? Okay, now we get some interesting ones, sometimes uninitialized. So X11 display is used uninitialized if this loop exits because the condition is false. And we're talking about this loop right here. But it's talking about X11 display. Oh, I see. So here's X11 display, right? And what happens is I don't understand why that's sometimes uninitialized there. Because we don't see any setting of X11 display anywhere up here. It happens right here. Did I just straight up forget to set the display? Like, it's being set if we couldn't parse it. But if we could parse it, we should be setting it. So if we've got D, we're going to want to say X11 display, and we're going to do a scratch allocation here. And the amount we want to allocate is going to be the amount of characters between S and D. Or S minus 1. Because S is the pointer to after the dot. So I maybe just want to keep track of, if we find the dot, where is it, basically. So then we're going to say the display length is going to be, depending on whether we got a dot. If we did, it's going to be dot minus D. And otherwise, it's going to be the string length of D. So then we're going to allocate the display length for the string. And then we're going to do a memcopy. And I believe that's like destination source. Yeah, destination source length. Oh, and then we're going to want to allocate this +1 because we need the null delimiter at the end. So we're going to pass it the destination. The source is going to be D. The length is going to be... Okay, actually... we want to do that. And then we want to say... just make sure there's a 0 on the end. So I think that should account for properly parsing out the display. And again, I'm not totally sure I want it as a string. But for now, we're keeping it as a string, so this is what we're going to work with. And we need to declare the length. Changes sign. So I'm just going to cast both of them to size T. The Windows struct is getting padded, but I think that struct is going to be changing. So, and I do like seeing when there's padding, so I'm just gonna ignore this warning. Next, 467, control reaches end of non-void function. Oh, these. Of course, now it just says that E is uninitialized. I mean, we don't care. Just ignore it. We're not gonna fill that out. It also complains that context is uninitialized when used here, but we're passing it into the thing that initializes it. So again, I think we're just going to ignore this one. And then the global variable, it complains about no previous extern declaration for non-static variable environ. I think that would only matter if you're not doing a Unity build. Because like the only reason I can think of that you would warn about that is because if there's no other extern declaration of that variable in the code base, like in another translation unit, but it's not marked static, then either you're not declaring it somewhere where you should be, or it should just be marked static. I think that's why it's warning about that. So I'm wondering, should I just silence that warning? Like, what all does this warning tell us? I'm wondering if I should just disable that warning. It seems like it's only used for extern and static to help you get those correct in your program. But we're doing a Unity build. So I think we don't care about that warning and we're going to disable it. Okay, now we're down to 3 warnings. So it's the padding of the window type, which again is probably going to change over time as I implement this backend. Control reaches end of non-void function. And that was one where it's just we haven't implemented the function yet. And this one, context is uninitialized when used here. That's because we're initializing it there. So yeah, those warnings are fine. And now we just need to implement memset. Now I wonder, can we just, like, is there a built-in for memset that we can just use? Yeah, and this is a thing I noticed with memcopy, which is why I implemented my own memcopy, was that it will occasionally replace it. If you use the built-in, it'll replace with the libc version. But what I'm wondering is, does this a similar kind of thing happen with memset? So do we need to implement our own memset, or can we just use a built-in? I mean, I guess we can just experiment and see what happens. So what we're going to do is we're going to try making memset just be a macro that calls built-in memset. And if that doesn't work, then we'll need to actually implement memset ourselves. let's say this is needed for initializing structs. I think arrays too. Because C sucks. Mem copy or mem set. So it takes SCN and we're just gonna call built-in memset like that. We're still getting undefined references to memset. How many undefined references did we have before we did that, though? Looks like the same ones. So let me see when things get included. So Linux x86-64.c should get included right away, which is defining memset right here. So I take it what's happening here is memset is expanding to built-in memset, or maybe the memset calls might get generated. Well, I was gonna say the memset calls might get generated. Actually, yeah, because the VA start, the VA end, the VA arg, those we actually call, but we're not calling memset. The compiler is generating calls to memset, and that is likely happening after the preprocessor is run. So this probably never gets expanded. So we might need to actually do this as not a macro, but as a function. So what we're going to do is try this. We don't have size t at this point. Is that? Yeah, that's defined right there. So let's just move it. Let's put it by the mem copy. It's still giving us undefined references to memset. So why would that happen? I mean, I guess maybe it's like, I'm thinking it's maybe a chicken and egg situation where the built-in memset is calling, like it's generating a call to the memset function, which is in turn calling the built-in memset. But I don't know why that would generate undefined reference to memset as the error. I'm a little bit confused about that. But I mean, I guess we can just implement memset. So memset fills the first n bytes of the memory area pointed to by s with the constant byte c. So we're just going to write it the naive way. So I'm just going to say while n, that's what we want, right? S I don't know, do we really want to count that way though? We might just want to do it as a for loop. And then we're going to say si is going to equal c. And I think we need to cast s because it's a void pointer. But we'll try this and see what happens. And what's it return? It must return a pointer to the memory area, so just return s, right? Yeah, that's what I thought. We need to cast it. Now, interestingly, it says it fills the first n bytes with the constant c. C is defined to be an integer. But we're just going to roll with it. So I'm just going to downcast C. So that cast needs to just be casting S. 3 warnings generated. But yeah, we still get the undefined reference to memset. So why does defining memset not shut it up? According to this, memset is usually implemented as a macro. So this is pointing out what's generating the memsets, but I know what's generating the memsets. I want to know, how do have my memset used? So I wonder if we set the triple differently, like the target, if it would avoid using memset. But I don't see why it can't just use my memset. This guy says he added a dummy memset function and the linker was happy with it. My linker is not happy with it. And I don't understand why. I mean, I compiled this, right? Yeah, I'm just really confused right now. Why it wouldn't use my memset. Let me take a look in the muscle source code. So it looks like they actually define memset in assembly. I don't know why. So they also defined memcopy and memmove in assembly. So they've got a nice optimized memset implementation here. But yeah, I don't understand why it wouldn't use my memset that I provide. Hmm. Like we can try copying the one from muscle to use and see if it likes it when it's in assembly, but I don't know why it would make a difference whether it's in assembly or not. Like my memcopy, I mean, I guess the compiler is maybe not generating calls to memcopy. Hmm. I mean, it shouldn't be mangling the name. Does it mangle the names? Like, main is not mangled, right is not mangled. So I should have a perfectly valid memset symbol that's being generated. I am incredibly confused right now. Provide own memset. Now this person says to convert it to unsigned. I converted it to signed because I was thinking, well, you know, the int is signed. So would it make a difference? I mean, I guess it would make more sense to just have it be unsigned because then you're, you know, just truncating the high bits that don't fit. Whereas if you have it be signed, it preserves the sign of the character that you're passing in through the int. I guess I don't know what the preferred behavior is in this case. Oh, okay. This person says there is a standard. It's just bad API design that they made it be an int because they're saying, uh, you know, this person is saying it's wrong usage of the caller if you pass a value that doesn't fit in a char. So let's take a look at the C standard. Memset. So yeah, it does actually say that. Fair enough. I don't know why everyone is using while loops when they're implementing it as a for loop. Like they're actually doing a for loop just using while. I mean, while is like lower. You can implement for in terms of while, but like what's the point? The language provides for. I mean, this one is destructively using the length parameter instead of having a separate variable for it, which, that's fair, I guess. Might as well do that in ours. Well, no. You wouldn't want to do it that way because you're doing this comparison. Well, okay, they just changed the comparison. So while you have a valid length still. That seems fair enough to me. We're going to do it that way. Although then we're setting backwards, and I don't know if that has a performance implication. That's what I was thinking when I implemented it this way. I was like, I was gonna originally do a while loop and have it go from the back to the front, but I was like, well, that might actually have a performance implication. I honestly don't know. Um, well, okay, so what they're doing is they're just incrementing the destination. So they are copying forward. So by doing it that way, they end up having an extra uh, increment every loop. Like they do an increment and a decrement, but they don't need to do an offset um, when they dereference the pointer for the destination. So does the offsetting of the pointer when you do indexing have a performance implication is I guess the question there. And we'd have to benchmark it. And I don't really care. like I'm not like having Memset be a bottleneck. I just need an implementation of Memset. I think I like it as we had it. We could probably there's the thing you can do with the linker where you wrap um like you wrap a symbol. So you define it as like underscore underscore wrap underscore memset. And then in the linker, you tell it you're wrapping memset to point to that function. That's something they do in the Freedom E SDK. I wonder if that would work. And then I'm also wondering if we mark it as freestanding, would it still like generate a good um, like ELF executable that can run on Linux? Because the code itself should be perfectly fine for freestanding. Uh, it's not actually freestanding because we're making calls to system calls in inline assembly, but So maybe there's some fancy flag like that we could use. But I'd really like to just be able to provide my own. I think it would be better to try to wrap it than try to use the freestand thing. So I'm going to try wrapping it first and see if it'll use that. So the way we do that, and if this works, we're going to do the same thing to memcopy. I think you do it like that. Let me check the Freedom E SDK. I think it's under BSP librap. Oh, so that's interesting too. There's a start group, end group thing. So you can have spaces in your flags. I was wondering about that, if it was possible to have spaces. Okay, here we go. So the thing you do is you do dash dash wrap equals, and then the symbol you want to wrap. And then let's just take a look at an example. So yeah, you do underscore, underscore, wrap, underscore, and then the symbol. So this is my memset. And then we're going to go to build.d, and we're going to say in the linker, I guess I don't have linker flags that are specific. to x11. I do for xcb though, so let's just make one for x11. So I think it was like this. You've got to be kidding me. So the linker is happy to change memset to wrap to use a wrap memset, but it still doesn't see our memset, even though I have named it appropriately. Why? Why do you do this to me? I don't understand. It's right here, linker. It's right here. What are you doing? Let's try the freestanding thing. So what was that flag? It's just dash freestanding. Unknown argument. This says there's supposed to be a double F. Does Clang specify this? Okay, yeah, it's a double F. Let's keep that open. So it's compiling freestanding now, and it still has no problem actually compiling, just like before, but the linker still complains. So did it change anything in what the linker is doing? I am still completely confused. I have no idea why the linker can't see my memset. And yeah, it doesn't change what the linker does if you tell it to compile freestanding. So I'm just going to take that right out. Man, I have no idea. So the first thing that happens in main.c when the preprocessor runs is include unity.h gets expanded. That has all this in it, and if we're on platform X11, which we are, then we include Linux x86-64.c, So this gets expanded. And that provides memset right here. So I really don't understand what the problem is. I mean, I guess we can take out the wrapping stuff because that obviously doesn't help. So with that, I think I'm gonna call it there for pcalc. It's time to do a risky business stream. So I don't know what I'm gonna do about this. uh, Maybe I'll try to make a simple test case of this and post it on Stack Overflow or something. Post it on Handmade-network. I don't know. But that is a problem for another day, I guess. So everything I have open right now is for pcalc. Oh, and I better end the recording.